Hi, my name is Mani Alikhani. I am Dean and Professor at CTOR Academy, and I'd like to welcome you to another session of CTOR channel. Today's discussion is semi-restricted design. If you remember from the previous discussion, free object design, when the anchor unit applied the force to the target unit, it was not able to control the type of movement of the target unit. The type of movement of target unit was defined based on the relation between this line of action of the force and the center of resistance in that design. However, when you apply a wire, or in a linear case, a material such as polymer, between the anchor unit and the target unit, anchor unit controls the type of movement of the target unit. The target unit is not completely free to go any place it wants. It is controlled by the anchor unit. Due to this control, this is called semi-restricted design. It is not free anymore. Semi-restricted design has three main applications in orthodontics. One application, when we have a major horizontal movement. If you remember from the previous discussion, free object design is not good for the major horizontal movement due to the big moment that appear in the system. The second application is minor tooth movement, and the third application during the finishing stage when we wanted to have the precise movement for finalizing the location of the target. Let's start with the first application. Assume I want to retract the canine. I can just apply a force from anchor unit to the target unit. The still system would be free object design. In that case, the anchor unit does not have control on type of movement of the target unit. The forces that appear in this system are considered primary forces. Primary force on the target unit has been shown as blue arrows, anchor unit as red arrows. The outcome of these forces on both target unit and anchor unit cause uncontrolled tipping because it's a free object design and the type of movement is defined by the relationship between the line of action of the force and center of resistance. And because the line of action of the force is far from the center of resistance, you will have uncontrolled tipping due to the big moment that appear in the system. But what happens if we put a wire between the anchor unit and target unit and we apply the same forces? Again, the primary forces, action and reaction, appear in the system. Again, action on the target unit will appear as a blue arrows, the same moment, the same force, and reaction forces appears on the anchor unit as red arrows, same force and same moment. But the moment that the canine start to move, the relation between the bracket and the wire automatically produce a secondary moment that is the result of the couple that appears due to the interaction between the bracket and the wire, both in the target unit and anchor unit. These secondary couples that appear in the system can control and define the type of movement. Now, you will not have uncontrolled tipping, but it depends on the magnitude of the movement that appear in your system. You will have different type of movement, perhaps bodily movement. The fact that the anchor unit through the wire was able to control the type of movement of the target unit provides good control not only in the plane of movement, but in other dimensions too, because the couple appears also in other dimensions. That is the main usage of the semi-restricted design. And that's one of the examples where we are using semi-restricted design to control major horizontal movement. As you can see, the type of movement in semi-restricted design is not based on the relation between line of action and center of resistance. It depends on the couple to force ratio. The second application of semi-restricted design, when we have minor movements in our problem list, there is no major movement. In that case, by connecting all the teeth together and putting the wire there, we will be able to move both target and anchor unit simultaneously and receive a clinically acceptable result. It is semi-restricted design because we can control the movement, and because it is minor, does not require free object design. Free object design considered excessive. The third usage of the semi-restricted design is when we are finalizing a movement of our target unit. Assume we have a premolar that is severely rotated. To correct this premolar, we will apply a couple. That's a free object design. But as we are progressing through correction of the rotation, we reach to the point that by changing our design from free object design to semi-restricted design and engaging the wire to the bracket, we can finalize a precise movement due to the control that semi-restricted design provides for finalizing movement that free object design could not provide. I hope you enjoyed this session of CTOR channel. If you have not subscribed to our channel, please go ahead and subscribe, and please don't forget to press the like button. Thank you.